Hi everyone. In this video, we're going to take a look at functions as function machines, and we'll also take a look at f of x notation for Algebra 1. All right, so to start off today, we're looking at function machines. One way to think of functions is as a machine where you can input a number and then it goes through the machine, goes through the function, and then you get a number for the output. So for example, let's say we have the function f of x. We'll talk about what this means, f of x, a little bit more. You might have seen it before, but I just want to make sure we formally go over it. F of x equals x squared minus 1. All right, so we can think of this as a function machine. Here's our little machine. Here's our function, f of x equals x squared minus 1. And we can take an input, put it into the machine, replace it with x, and then we'll end up with an output. So one example is, let's find f of x when x is equal to 3. So in this case, 3 is going to be our input. We input 3. It goes through our machine to calculate what f of 3 is equal to, or what f of x is equal to when we input 3. We would replace x with 3. So 3 squared minus 1. So 9 minus 1, which gives us 8. So our output in this case is 8. So our x value is the input, what we put into the machine. We process it through the equation, and then whatever we end up with after simplifying is our output. So f of x when x equals 3, we see that our output is 8. Or another way to write this is f of 3 equals 8. So whenever we have function machines, that means we just take an input, we plug it in for x, wherever x is, making sure we use parentheses when we plug it in. And then when we simplify, whatever we end up with is our output. Okay, so next I want to talk about f of x notation. F of x is just another way to write y. So f of x is another way to write y. And you've probably seen this notation before and maybe even probably worked with it. I want to make sure we formally go over it though. So especially in middle school, you'll use y equals for a lot of things, like y equals 2x plus 3. And even in Algebra 1, we'll still use y throughout the year, but we also will be using f of x. F of x is another way to write y. Both of them just mean our output. So they're both just what do we end up with for our output. For example, with the function machines, what is that last number that we end up with? F of x is a little bit more useful, however. So first of all, when we're talking about inputting a value, so before we said when x equals 3, and we were looking at f of x equals x squared minus 1, we can write the output that we get when we plug in 3 as f of 3. So f of 3, this means the output when we plug in 3 or input 3 for x. So in other words, if we have f of a number like f of 3, we take whatever x is in our equation and we replace x with whatever we have inside of this parentheses. So as we did above, 3 squared minus 1 to give us 9 minus 1, which is 8. So here we're writing f of 3 equals 8. So this is a little bit more descriptive because we can see, it's a little bit more clear, what our original input was. So in this case, f of 3 is telling us we input 3, and then on the right side, what we ended up with was 8. This is a little bit less clear if we had y equals x squared minus 1. If we input 3, y equals 3 squared minus 1. Y equals, after we simplify, 8. So we see that our output is 8. However, we don't have that information of the input. So we don't see that 3 was our original input. So f of x notation can actually be a lot more useful to us. And that's one reason why we use it to talk about functions. F of x is also helpful if we talk about multiple functions. So that we're not writing a lot of y's. We could write f of x. We could write g of x. So we could use any letter we want in front of x to describe a different function, or a different, you can think about it as function machine that we put our inputs into. Okay, so I want to take a look at an equation, one more equation really quickly. F of x is equal to x squared. If we were asked to find a few values, like f of 0, we would just plug in 0 for x and get 0. F of 2, we take x and plug in 2, and we get 4. So we're just replacing x with whatever is inside of the parentheses here. F of -1, so here with negative numbers is where it's important to make sure we use parentheses, because -1 squared, we have a negative times a negative, which actually gives us +1. I also want to look at a graph and how we can use a graph to identify these values. So let's say this is our graph of f of x. So we have like a U-shaped graph. We have 1, 1, -1, 1, 2, 4. So here we have a few points on our graph. 1, 1, 0, 0. And here we have -1. So if we're asked to find f of 0, we look left and right. So we're looking at the x-axis. So left and right, that's our input. Our input is 0. And we see that our output up and down is 0. F of 2, so we're looking at 2 on our x-axis. And if we go up, we see that our point is here, and our output at 2 is 4. So f of 2 is 4. Finally, -1. So here we have -1 on the left here. We're going up until we hit the graph. So we have a point there. And we can see that our output, or y value at that point, is +1. So f of -1 equals +1. So here we looked at how we can find the output for specific inputs like 0 to -1 using this notation. We also looked at how we can use a graph to answer or to find the outputs for specific inputs using the f of x notation. So in this video, we talked about function machines, what those mean, and then we also talked a little bit about f of x notation and how to work with f of x notation.